So okay, so solve modern equations. There's yes, ma'am. Let me know if you ever can't see anything. I'm so out of practice of using this thing that I'm awful. Okay, so solving log equations. Here's the deal. There's really three things you sort of need to know. One of them is log properties. You have to know log properties. You have to know how to change the sort of exponential equations into a log equation. So if you have something like this, so just kind of keep it in mind. If you have this thing, right? That's the same thing as I can rewrite that as log base b. Can somebody get that, please? All right, I'll get it. The YouTubers are going to be so upset. Come on in. Okay. I can rewrite this thing to look like this. Okay. Cool. So this is one of the things you need to be able to do. The other thing that you need to sort of understand, and it's not too crazy of a jump, is if I have, so here, I'll just bracket that so that's its own thing. If I have some equation that looks like this, log base b of a equals log base b of x. If you have that, then you know that that's true. Okay? Okay? If one of those is true, then the other is true. Okay? You're going to use that a lot. Now, the easy ones will just look basically like this. So you're going to have basically two different versions of log equations. You're going to have easy ones and hard ones. Easy ones, you just are going to get handed two logs are equal to each other. You essentially drop the logs so the inside's equal to each other and roll. The harder ones are going to require you to mess around with the log properties first. And then you may end up with an equation that looks like this, or you may end up having to do this guy. So it just kind of depends. What you're going to have to do is be sort of flexible. And when you get a log equation, they always look gross because they just say log in them. It just doesn't look nice. And your job is to make it look nice and get it into a thing you know how to solve, which is essentially going to be just a linear or a quadratic equation. Okay? For the most part, yes. You will have a calculator that you're going to have to do some algebra. Like you're going to have to do some manipulation. But yeah.
Like to solve it, we have to use calculator.
Yes, ma'am. So let's talk about the easy ones first. Okay? We're going to do a really easy one right off the bat. So here are the easy ones. So in other words, that's when you got log equal to a log. Not a whole lot to do. Okay? So if I've got something like this, log base 3 of 2x equals the log base 3 of 8. So to solve this, what you're going to do right off the bat is I noticed that both of them both of those expressions have log base 3 in them. I don't have anything on the outside of the logs. It's just log of something equals log of something. So basically what that means is I can drop these logarithms and I can say that means that 2x must equal 8. I want you to notice that something that I could do if I really wanted to, but I did not do. Okay? I did not evaluate log base 3 of 8. If I had, I could still solve for this and still go and get an equation that I can solve, but it makes the problem harder. I'm going to give you today sort of an opportunity to sort of look at 2 different strategies and pick which ones you like better. So you'll get a chance to see what I mean. I'm going to divide both sides by 2 here. And I get that x equals 4. Sweet. Questions on that? Awesome. So I can try to make something look more complicated. So I'm going to use, and again, this is just the case with any base. So let's say I have natural log 2x minus 5 equal to natural log. Just make sure I'm not crazy. Okay. So this has a lot more junk in it. But again, kind of game it a little bit. You're sitting in math class, that we're learning about logs. So that I'm going to be asking you to take care of log stuff. Take a look. I see that I've got natural log on both sides. I don't have anything outside of them that need to be taken care of. So I've just got this. So what I can do is I can say, okay, well, I know then that this must be true. So just some quick reminders from back in Math 1, when you've got x's on both sides, you've got to essentially get those together before you can move on much. You can balance however you want to, and if you want to build and unbuild, have at it. That's totally fine. If you do build and unbuild, you are not able to till you get to here. So you have to do that minus 2x step first. But now you could go through and you can either balance or whatever. Go there and divide by 4. Okay, we all right with that? Everybody good?
Yeah.
Sweet. Okay. No worries. you can make these, like the actual solving part, get as complicated as you want, but the main thing that we're picking up from this is the drop in the logs, right? Like that's, nothing else in this is new. I'm going to do one more just so that you know that this is out there. Okay. So we could have this. Okay. Fine. Not a big deal. I see I've got common logs on both sides, so I can drop them. So then I'm just looking at x minus 5 equals 20. Okay. One thing that I need you to remember on these, so we're solving a square root equation. I do not intend on giving you any that you have to factor to solve or to use quadratic formula to solve. You technically could in this, but I'm going to keep it just to where it's just solving by square root. Add 5 to both sides, so I get x squared equals 25, right? The thing that I do need you to remember is that when I square root this to solve, square root of 25 is 5, but also negative 5 times negative 5 is 25. So when you square root, you get two answers. You get x equals 5 and x equals negative 5. I don't mind if you just write plus or minus 5. That's totally fine.
If we just write square root 25, is that still fine or no?
If you said x equals square root of 25, yeah, we need to go ahead and square root that. The thing that people are going to forget, and it's easy to forget, is this plus or minus. So when you see a squared, you just need to know, okay, I'm going to end up having two answers here. Okay. That's not too bad, right? You're basically just taking these equations, you're dropping the logs and rolling on, right? Nothing too wild. So we do have to be able to do these log properties in there with it. Okay. So this is when they start getting to where I'm going to have to start actually paying attention to what I'm doing. So these are going to be tougher examples. Okay. So now they're going to fall into one of these two categories. They're either going to end up with something with log on both sides, like we just did, or you're going to rewrite and have to evaluate some exponential, and I'll show you what I mean. So let's start off with something that's not too wild. Let's just go, and I'm going to have to kind of make these up as I go because I don't have any here. So let's go log base 5 of 4. Let's do it says log base 5 of 4 plus log base 5 of x plus 1 equals the log base 5 of 16. Okay, so we're going to have to start paying attention here because Sometimes it's beneficial to evaluate logs, sometimes it's not. Here, what I notice, because we've been doing log properties for forever, is that I've got 2 logs being added here, right? So I know from yesterday that really what that is that would be the same as log base 5 of those 2 insides being multiplied. So let's do that. Now you have to pay attention here because I've got 4 times a binomial, which means, and I'm going to write this out the long way here. Okay. The reason that I did that is because I see that I've got logs on both sides, and then if I combine these, I get right back to one of those problems that we were just doing up above. So we go from a tougher problem to a pretty easy problem. Now I can drop my log base 5s, and I've got 4 x plus 1 equals 16, like that. Now, if you want to distribute the 4, you can. You actually don't need to, okay, as long as you're paying attention to Tim Doss. If you were a big build and unbuild fan, then this is the perfect time to sort of do that. What I'm going to do, I'm going to stick with balancing right now, but what I'm going to do is I'm just going to divide both sides by 4. So I've got x plus 1 equals 4. Subtract 1 from both sides, and I get that x equals 3. Is that okay? So we added just one more step on. We had to deal with what you need. Which one? All right. We just had to deal with those log properties first. Sure, I don't skip these. Okay. Are there any issues, questions, anything like that for these right now?
Well, whenever we take the test on this, is it gonna be like us solving like this or the way that we have it?
Yeah, so there'll be a section where I give you problems that pretty much only have variables in it that I ask to see the log properties. So I'll just ask you to say like, hey, condense this as much as possible or expand this. And then, but this right here is going to be this is what we're working towards right now. Yeah. Good question. Okay. So let's look at something a little bit different. So what if I have something like this? I just made that harder than I wanted it to be. Hold on a second, let me think. Turn this 3 into an 8 real quick for me. It's all right. So what do you notice about this one? It's different. Right. So we don't equal to a log. So that means this whole drop in the log thing is going to be kind of out the window now. So what I'm going to have to do when I see an equation like this, I know I'm going to have to come back and deal with this thing, okay, where I'm going to be rewriting a log into an exponential. So what that's going to look like is this. First of all, I notice I have this plus out here. So I'm not going to be able to rewrite that log unless I have everything condensed down into one log equals a number. Okay? So I've got this plus. This is light work compared to what we were doing yesterday. We know that that is multiplied. So we get that. Now, we're going to take this guy. And we're going to rewrite it as base squared equals I remember rewriting those a couple days ago. That's why we were doing that. So now I've got something that, again, just looks like something I know how to solve. The first couple steps that you're going to take in these, all you're trying to do is basically figure out a way to get rid of the logs. You're going to do that one of two ways. You're either going to get log of some base equals the log of some base, and you're going to drop the logs, or you're going to have to rewrite it as an exponential. One of those two things are going to happen. Once I do that, so I'm here now, I know that 4 squared is 16, and now I can just solve. Now with these, please remember, okay, and this is important to keep in mind. I'm doing some examples that we're getting all integers for our answers. So you don't have to get integers for your answers. If you think about when you take the log of some number, unless it's just a really specific case, a lot of times you get an irrational number. So, a bunch of decimal places. That's okay. Let's do one that might have that. I don't know if it will or not. Good with that? Okay. So, if all of a sudden now I've got this, let's make this a little bit more. I wish it wouldn't have been natural log. That would okay. That's all right. We'll just roll with it. We're gonna get a gross number. I don't know what number we're gonna get, but it's not gonna be a nice number. It's okay. We're just gonna roll with it. Okay. Okay. So here. I noticed that I don't have a log equal to a log, so I'm not going to be dropping logs, I'm going to be rewriting. So it's helpful to look at the equation right off the bat and go, okay, am I going to end up dropping these things, or am I going to end up having to actually rewrite? So if I know I'm going to rewrite, then I'm just trying to get it to a point where I can. So that's what we're going to do. I've got this subtraction happening. Well, subtraction means I've got division happening on the inside. So I'm going to get the natural log of x squared minus 6 divided by 2 equals 4. Okay. Now, this is a good example to look at, because what I have to remember is natural log is just, it is a logarithm, right? What's its base? What did we say its base was? Remember?
2 point something.
Yeah, it's 2 point something. It's E, right? It's Euler's number. So this is the same thing as this. I don't need you to rewrite this step, by the way. So if you don't want to write this down, that's fine. But just remember this. That's the same thing. Okay? It just shows up enough that people take shortcuts and write natural log. So when I rewrite this thing, here's the way I'm going to rewrite it. I'm going to rewrite this as E. So you should write this part, though. E to the 4th equals x squared minus 6 divided by 2. Okay. So we've got some gross numbers to deal with. Here's where our calculator is going to come out. So if you're using one of these yellow calculators, take a look at where E is at. Right? So E is right above your divide sign. So you're going to hit second divide. So I'm going to go E to the 4th. And we're going to get a number. I have no idea what that is, okay? We're going to round. I'm going to keep it nice and easy. I'm just going to call that 54.6, and we're going to roll from there. Sound good? Okay. So 54.6 equals x squared minus 6 over 2. Now we're just going to go through and solve. Multiply by 2 on both sides to get rid of this fraction. Okay? Please look and remember this. I see this mistake all the time. When I do that little multiply by 2 to clear the fraction, I do not make this 2x minus 12 or 2x squared minus 12, right? I don't actually change any of those numbers. I'm just clearing this fraction. It was being divided by 2. I multiplied by 2 to undo that. Add 6. Now I have no idea what that's going to be. So we're going to square root 115.2. So I get what did I forget to do? Very end. $10.73 equals x. But remember, we just square rooted, right? So what I got to make sure is out there.
Oh, plus minus.
Yeah, the plus or minus. I should end up with 2 answers.
Oh.
Okay?
Did it make 2 steps?
I do. I went and got some. Here you go. I'll set this in there. Is that okay? I'm not asking if it's great. Is it okay? Is this the most fun thing you've ever seen happen in the world? Oh my gosh. How exciting. Okay, do you need to see one more, or do you want to try to rewrite some? So here was my plan. I've already ran more time than I was planning on doing. So I've got some that I would like to just try to rewrite without having to do the solve part. Okay, just try to get it into an equation. But honestly, after writing these, I think at this point we might as well just go ahead and kind of try to solve some. Do you need to see one more before do that? Okay. Well, if you'd like to see more or more fun equations, like and subscribe to this video on my YouTube channel. Soon to be, what did you call it? Did you give it a name? Oh, okay, never mind. Like and subscribe. Okay, sweet. Let's try some. Let me pause this.